Hello again, my name is Andrew Slate. This is the third and final presentation of our three-part series on mycotoxin sampling. In this presentation, I'd like to present the FAO mycotoxin sampling tool. So far, we've seen two presentations. Dr. Whitaker presented designing mycotoxin sampling plans in part 1, and I presented representative sampling for mycotoxins in part 2. So the importance of representative sampling is that the mycotoxin sampling plan development is not valid unless representative sampling is performed. So with the first two parts, you have a valid sampling plan. For this third part, I want to illustrate how the FAO mycotoxin sampling tool can be used to develop multiple sampling plans for comparison. So a little review. In order to develop a sampling plan, you need a variability distribution theory model. That way you can input the test procedure specifics, the accept-reject limit, and what is produced is an operating characteristic curve, and from that you can determine seller's risk, buyer's risk, mycotoxin removed, and the cost of the plan. So how many of these variability distribution models are available in the tool? Well, this is a chart or table showing the experiments done on various commodity mycotoxin combinations, and all of these are in the tool. Again, the tool can create an operating characteristic curve for any mycotoxin testing plan. This particular curve is for aflatoxin in shelled corn for one 5 kilogram laboratory sample where it was prepared with a Romer meal, and a 50-gram test portion was extracted and analyzed using HPLC. The accept-reject limit was set at 20 ppb. So this operating characteristic curve shows the performance of that testing plan. The axis on the bottom, lot aflatoxin concentration in parts per billion, total aflatoxin. The y-axis shows the probability of accepting the lot. So for a lot that is truly at 10 ppb, if you go up, it crosses here, and that's 90%. So this testing plan should accept 90% of all lots that are truly at 10 ppb. For all lots at the regulatory limit in this case, which is 20, this testing plan should accept roughly 55–56% of all lots tested that are truly at 20. And all lots tested by this testing plan that are truly at 30 ppb, which is above the limit and should be rejected, about 24% of the lots will be accepted, and all others will be rejected. So this is how we use the operating characteristic curve. We simply look at true lot concentrations. We go up to where the line crosses, and we can see how many lots, or the percentage of the lots at that concentration, will be accepted by this testing plan. So at 40 ppb, what is this? Roughly 7% of the lots will be accepted. That means 93% will be rejected. So if all lots tested at 40, this testing plan rejects about 93% of the lots and will accept 7% of the lots. And accepting a lot at 40, of course, is an incorrect decision. Now, once you have your performance or OC curve for a given testing plan, what does that mean in terms of number of lots rejected and number of lots accepted? This bar chart displays a distribution of lots. Let's say for a bad crop year. The height of the bar represents the number of lots at each concentration. So for this crop year, and this is based on 500 total lots, we had about 50 lots at 0. At 5 ppb, we had just a little over 140 lots. At 10 ppb, there were about 95 lots. So the total height of the bar shows the number of lots at each level. And if you add up the total number of lots across here, you should have 500 lots. Now the OC curve tells us how many lots will be rejected and accepted at each point. So this testing plan, the previous slide, this OC curve, 5 kilogram shelled corn, 20 ppb accept reject, 50 gram test portion, comminuted in aroma meal, analyzed by HPLC, gives us this accept reject at each point. So the red are the number of lots rejected at each point. So you can see a lot of lots rejected, especially above 20. The higher the true concentration in the lot, the higher the probability that it's rejected by this sampling plan. But mistakes, errors are made. Some good lots are rejected here, and at 20, some good lots are rejected. At 25, these are all bad lots because 25 is above our limit of 20. So the accepted lots at 25 are incorrect decisions. We've got a few incorrect decisions. But as you can see, very few lots are accepted above the accept reject limit. And that's a good thing because that's removing a lot of mycotoxin from the food supply. So this is a bad crop year. What happens in a good crop year with the same testing plan? Let's look. So here we go. This is the distribution of lots in a good crop year. You can see at 0 there's 150 lots. At 5 there's over 200 lots. 10 there's over 100 lots. There's very few lots out here at the high concentrations because it's a good crop year. We see fewer rejections, total rejections, which is good in a good crop year. Because above the accept reject limit of 20, we see very little accepted lots, very little green. There's some right here. Most all lots out here are rejected. We just don't have many lots out here because it's a good crop. There's not much aflatoxin in this crop. So it's the same testing plan. And sometimes when there are a lot of rejections, like in a bad crop year, there's some thought that there's something wrong with the testing plan. Well, no, the testing plan's performing exactly as it should. There are a lot of rejects because it's a bad crop year. So let's go next. And by the same token, in a good crop year, there won't be many rejections, but the testing plan is still performing as it should. So that brings us to the sampling tool. So we're going to open up the sampling tool and actually do some work here in a moment, but I want to talk about the tab layout. When you go to the website, there's an instructions tab where there's a user's guide. And that's a very good place to start. Just go through the user's guide. It's extensive. Then there's an Edit Plans tab, and that's where you input the plan description that you want to look at. There's a Chart Results tab, Table Results tab, Plan Summary tab, and an Export to Excel tab where you can export the information to save or play with the probabilities you've generated in the tool. So on the Edit Plans tab, you select your commodity and mycotoxin that you're interested in. You specify a regulatory limit. You specify the number and size of your laboratory sample. You specify the size of your test portion, and you specify the number of analyses you're going to perform on each test portion. Finally, you specify an accept-reject limit. So again, you've seen this before. We want to generate an operating characteristic curve, which is basically the performance of your sampling plan. The area to the left of this regulatory limit, but above the curve, are good lots rejected. That's your seller's risk. And the area below the curve, but above the regulatory limit, these are bad lots accepted. And that's your buyer's risk. And that concludes the show. So now let's go to the FAO mycotoxin sampling tool. Again, this is the instructions tab. It tells you all about the tool, and here's a link to the user's guide, which we can click on that just so you can see what the user's guide's all about. It's taking a little time to load. There's a contents page. Very good reference material here. But this is where you go to understand all about the tool, what it does, operating characteristic curves. A lot of this stuff you've already seen. So let's go back to the tool, and let's click on the Edit Plans tab. And here we want to select our mycotoxin commodity, and we're interested in aflatoxin in shelled corn. This is a kernel count per kilogram, and it's not necessary to change this value, but it's part of the model. The regulatory limit by default is set at 10. You can choose any regulatory limit you want. Let's say we want to look at 15, so we stick that in there. The analytical variance type, there's within lab and among lab. And among lab is basically double the within lab variability, and so we'll choose that. So we have plan 1, we can add a plan. And we can add another plan. Now, we can have as many as, I think, 10 plans, but we're just going to stick with 3. And we're going to use a 5 kilogram sample for each of our plans. And we're going to say 1 laboratory sample. Here's where we're going to make some changes. For the test portion size, we're going to do a 5, a 15, and a 50. Let's just see what the difference is. The number of aliquots for each tested for each test portion is going to be, we're going to leave that at 1. The accept reject limit, we're going to leave at 10, which is equal to the regulatory limit. So we're done with that. We click Save Plans. Now we go to Chart Results to see the results of our selection. This will tell us about the performance of our plan. In this cell, we specify the maximum lot concentration to compute probabilities. And for corn and aflatoxin, let's make that 100. And hit refresh. Okay, the first chart shows the magnitude of the variance for each of the three plans. And remember, each of these three plans, this is a 1 by 5 kilogram less than 10, this is a 1 by 5 kilogram less than 10, this is 1 by 5 kilogram less than 10. The only difference being our test portion size. Here it was 5, here's 15, here's 50. And this is the total magnitude of the variability for each of the steps. Blue is sampling, and yellow is sample prep, and red is analysis. Now, as you can see, for the three plans, the 5 kilogram sample gives you the same variability. Again, the blue section is the magnitude of the sampling variability, and since all samples for the three plans are 5 kilogram, that variability is the same. However, a small test portion size of 5 grams gives you a large variability. 15 is better, and 50 is even better. The analytical variability in the red, as you can see, is the same height, roughly, and therefore doesn't change for the three plans. This is an important chart in that it tells us if we want to reduce the variability of any one of these plans, where's our target? Well, with this first one, obviously we need to reduce sample preparation variability. When we use a 50 gram test portion, our sample prep variability is roughly the same as the sampling variability. This is the case with shelled corn. I've noticed that sample prep variability is really high. Normally, sampling variability is the largest of the three. This is the same chart, but it's just a percentage basis. Here we see that sample prep variability represents 90% of the total variability. Analytical is only 1.52% of the total variability, and sampling is only 8.4% of the total variability. With this sampling plan, a 50 gram test portion, 5 kilogram sample, and HPLC analysis, the analytical variability represents 8% of the total error. Sample prep represents 47% of the total variability, and sampling represents 44% of the total variability. So now, what do our three operating characteristic curves look like for these three plans? Number one is the 1 by 5 less than 10 with a 5 gram test portion. So for lots at 40, that plan will accept 20% of the lots tested. However, using a 5 kilogram sample and a 15 gram test portion, at 40, this plan only accepts roughly 7% of the lots tested. And finally, the red line, that is the performance curve for the sampling plan with 5 kilogram sample and a 50 gram test portion, and it accepts almost 0 lots that are truly at 40 ppb. So by selecting a plan that uses 50 gram test portion rather than a 5 gram test portion, you can see we've greatly reduced the number of lots accepted at 40. So this is the information contained in the chart results. We have similar results here, but they're in table form. Again, this is the variance This is the magnitude of the variances. For the first testing, for the first plan, the total variance is 433. And then for the 50-gram test portion size plan, we only have 82 for our total variance. Again, the second table, these are just percentages of the total variance for each of the plans. And here's the accept probability data. So for any lot aflatoxin concentration at 10, for instance, these are the accept probabilities for each of the 3 plans. Plan summary. So this just gives a summary of the parameters for your plans. The regulatory limit was set at 15, the accept reject level was set at 10. As you can see, all the plans are the same except for the test portion size. So this tells us that with shelled corn and aflatoxin, it's important to use as large a test portion as possible. So the analytical methods used to test aflatoxin in shelled corn are benefited by larger test portion sizes, not the accuracy of the instrumentation or the method. This illustrates that putting too much emphasis on the accuracy of the method or the equipment used is not as effective as having a method that will allow for larger test portion sizes. So we could simply go back to our OC curve and see that. It's taken a moment. And when you look at these OC curves, they all use HPLC analysis. The only difference in these curves are the test portion sizes. This is the 5 gram, this is the 15, that's the 50. Now, the final tab, Export to Excel. I'm going to do one just... Okay, I want to look at increments of 0.1 in my data. And I want to go up to 100. And I'm going to say Export Results to Excel. So I got the export, and I can go over here to my downloads. And there it is, OC Report 2014, December 17, and this is just a random number assigned to this file. But if we open it up, and Excel comes up, we'll enable editing. So here's the information, and it's all neatly in Excel. So if you want to create tables in Word or PowerPoint, it's all here to copy paste. It's a lot easier to get the information out of here than it is out of a web browser. Here's our variance charts. This is variance magnitude. This is a variance by percentage. Here are OC curves, and here's the data that we requested. Our accept probabilities for the 3 curves at these concentration levels. And since I specified a 0.1, I get probabilities at every 1/10 of a ppb. There's another tab, which is raw data, and this is all the data. And notice these were generated at 1/100th of a ppb increment. So we have all the probabilities. You see they start out at nearly 100%, and they go down from there. Okay, so I'm going to close this sheet. I'm going to come back here. I'm going to go back. Now that we have that information saved in the spreadsheet, we can go back to Edit Plans, and we can do the same thing. We can say, okay, we want to use 50 for our test portion sizes for all 3 plans. Oops. So we make all those 50. However, we want to know, can we get away with a 1 kilogram sample or maybe a 2 kilogram sample? Do we really need to use a 5 kilogram sample if we're able to use a 50 gram test portion? Alright, let's save those. And now let's go over here to our chart results. Click and wait. Okay, when we reduce our sample size, look what happens. For a 1 kilogram sample, we have about 175 for our sampling variance versus a 5 kilogram sample, which only gives us 36 for our sampling variance. Again, sampling variance is in blue, sample prep variance is in yellow, and analytical variance is in red. And the only difference between these three plans is our laboratory sample size. Again, percentage. So again, at 5 kilograms with a 50 gram test portion, our sampling error and our sample prep error are about equal, and analytical's really small in terms of the percent error. So why spend a lot of money on more accurate analytical equipment when it only represents 8% of the total error? Money is better spent in these two sections to reduce your variability. Now let's look at the OC curves. So at 20, a 1 kilogram sample is going to accept about 33% of the lots, whereas a 5 kilogram sample is going to only accept about 17% of the lots. So again, we can go over here to export to Excel, and we can, those look good, so I'm just going to say export results, and there they go. So I know I've saved those, so I can go right back to edit plans and look at something else. For instance, we could choose a different. We have these models available. You can scroll down. There's fumonisant in shelled corn. We can select that and generate operating characteristic curves for that. We have OTA in oats and wheat. And FAO is always looking for more models to add to this tool. So if it becomes a very useful tool, you can expect to see more aflatoxin commodity combinations available. Now another thing we can do is, let's go back to our 5 kilogram sample. So we got 5 kilogram laboratory samples for each of our three plans. But this time we're going to say, what if we require 2 laboratory samples to test less than the accept reject limit? And what if we use 3, requiring all 3 to test less? What happens? What does that do to the curves? We'll save that. Now let's go look at chart results. Okay, all of the variances or errors associated with the three plans are exactly the same because we require 5 kilograms, same laboratory sample size, same test portion size for all 3. The only difference between the 3 plans is with this one we require 2 samples to test less than or equal to 10, and with this one we require 3 samples to test less than or equal to 10. Percentages are the same, but look at the OC curves. If we only have one 5 kilogram sample required to test less than or equal to 10, this is the performance of the curve. Let's go back and change this 40 to, let's go change this to a 40 just so we can see. Here we go. Yeah, we stretch out the axis to 40. So now you can see if we require 3 samples, 3 5 kilogram samples to test less than or equal to 10, the curve is basically pushed to the left. The good thing about this is you see very few lots are accepted that are above the limit. However, if you look at the area above the curve, the good lots, there are a lot of good lots rejected with this plan. So the seller's risk is very high. A lot of his good lots are going to be rejected, but the buyer's risk is very low, because he's very unlikely to receive a bad lot. Now, if the seller can take the lots that are rejected by this plan and do something with them and save the value of the lots, then he's okay. He's not hurt. But if these rejects are lost, then this sampling plan is definitely going to hurt the seller. Again, when we're done with that, we just simply export to Excel. We click, and I always up this number, and I always make sure that's a 0.1 before I export. Okay, so that's downloaded. We're done with that. Again, we can go back to edit plans, and we can do anything we want. We can play with these numbers, with the sample size, number of samples, test portion size, number of aliquots, and accept reject limit. So this concludes this presentation.